Hey, so I want to go over just three of the exponent rules for right now. The first one, and I think this is probably the easiest one, is the zero exponent rule. So basically, when the exponent is zero, so like when the power is zero, the little number, no matter what the base is, the entire thing equals one. So literally, if you've got like 3 to the zero power, that equals one. If you have x to the zero power, that equals one. If you had 4x and that whole 4x was in parentheses to the zero power, that equals 1. I could have 10,000 g to the zero power. That still equals 1. So I'm going to erase these examples and um, kind of show you why that is if you're interested. If not, just forward to the next example. If you're going to do that, I do want to show you a situation where that doesn't work. So let's say we had, instead of in parentheses 4x, we just had 4x to the zero power. The x would become 1, but the 4 remains. So that would just be 4 times 1, and that would be 4. If I had, say, negative 4x to the zero power, that negative is outside the parentheses. That 0 should be inside the parentheses. That negative is outside the parentheses. So I'm going to do the 4x to the 0 power first and then make it negative. Okay. But the reason that all this to the 0 power stuff works is because I am taking, let's say I've got 3 to the second power. Let me do this in a different spot though. Let's say I've got 3 to the second power. Let's go even further. 3 to the third power. 3 to the third power is 3 times 3 times 3. That's 27. If I divide both of those things by 3, now I've cut that down to 3 squared. 27 divided by 3 is 9. If I divide again, I have 3 to the first power. 9 divided by 3 is 3. If I divide one more time, I have 3 to the 0 power, and 3 divided by 3 is 1. And that's going to work no matter what, because anytime you get down to where you're dividing something by itself, you just get 1. Now, I want you to remember that, because when we talk about negative exponents in just a second, this continuously dividing by itself is going to come up again. Okay, so let's go ahead on to the negative exponent rule, and I'm going to use this. I'm going to bring this right over to, in fact, let me grab this right here, see if I can copy it, and well, maybe I can. Let's see. Okay. So now, what would happen if I kept dividing? So if I kept dividing, so this was 1, if I continued to divide, I'm subtracting my exponents, I'm decreasing my exponent by 1. If I divided by 3 and divided by 3, now I have 3 to the negative 1 power equals 1/3. What happens if I divide again? If I divide again, which I can do 1/3 divided by 3, so I would get 3 to the negative 2 power equals 1/9. So 1/3 times 3. And that pattern is going to continue when we pass that 0 exponent threshold. What we get is 1 over, and then it starts increasing again. So we actually are getting smaller and smaller numbers, because 1/3 is bigger than 1/9. 1/9 is bigger than 1/27. But we just sort of start repeating the powers just in the denominator of a fraction. So let's look at a couple of examples of how that would work. Let's say we just had 3 to the negative 2 power. 3 to the negative 2 power is going to flip over and become its own reciprocal. Reciprocal is when you flip a fraction, so that when you multiply it by itself, you get 1. But 3 to the second power is negative 2 power, sorry, is going to become 1 over 3 to the second power. And then we always want to see if we can continue to simplify. 1 over 3 to the second power is 1 over 9. Let's say I had y to the negative 3 power. So that is going to be 1 over y to the third power. And since I don't know what y is yet, that's as far as I can go with that one. If I had something like 4x to the, I don't know why I keep thinking of 4x to the negative 4 power, that's going to be 1 over 4x to the fourth power. And I could actually simplify that a little bit further. 4 times 4 times 4 times 4 is 256. So it would be 1 over 256x to the fourth power. Let's look real quick at what happens when you're when it's already a fraction. Okay, so let's say we had 1 over x to the negative 5 power. I'm still going to flip my fraction and get rid of the negative. So I'm going to have x to the 5th power over 1, and anything over 1 is just itself. What if I had 7 over x to the negative 3rd power? All right, so I am going to split this up into 7 over 1 times 1 over x to the negative 3rd, so that my 7 remains. My x to the negative 3rd is going to become its reciprocal, and then x to the positive 3rd. So let's look at one more example of this before we move on to something else. What if we had 2y to the negative 5th power? Notice the negative 5th power only applies to the y. So essentially I have 2 over 1 times, now I'm going to switch this to 1 over y to the 5th power, and that just becomes 2 over y to the 5th power. Okay. And let's look at one more example. This is the multiplication rule, and you have been doing this when you multiply polynomials. So this is when you have something like 2x squared times x squared. We keep our 2, the x squared and the x squared. We add the exponents. So that would be just 2x to the 4th. If you had something like 8y to the 3rd times 2y to the 4th, 8 times 2 multiplies to give you 16. Y to the 3rd times y to the 4th multiplies to give you y to the 7th. Now you can add and get negatives. And in those situations, you might want to simplify a little bit further. So let's take a look at that real quick. So let's say you've got 2x to the 5th times 3x to the negative 7 power. So I'm still going to multiply 2 times 3 is 6. And then x to the 5th times x to the negative 7 is going to be x to the negative 7 plus 5 is negative 2. So now I want to check to see if I can simplify further. And I can by taking this 6 and flipping over the x to the negative 2 and making that 1 over x squared. And that gives me 6 over x squared. Now there's about a million different variations of this that you will see. We'll do some, practice problems and stuff like that. But with the multiplication rule, you're adding the exponents. every single time, no matter what the exponents are. If they're 0, if they're 1, if they're positive, if they're negative, if you're multiplying them, you're adding them. Now, what we can't do is this. That does not become, it is not equal to like 2xy to the 7th or something. It does not equal that. That's wrong. Because of these two things right here, they must have the same base in order for you to add those exponents. All right. And that is all I have to say currently about the zero exponent rule, the negative exponent rule, and the multiplication rule.